Welcome back to the next video in our APM project management series. This is looking at the PFQ exam requirement, so for the fundamentals exam. Just a reminder that this is not a definitive guide. This is to help you understand those concepts so that when you are revising for that exam, you've got something to pin this on. So this is not the end solution for your exam preparation. In this video, we're going to be looking at quality within project management. So some of you may have a pretty good idea around quality from other areas, but remember we're talking specifically about APM's take on this, which may be slightly different. So first of all, let's define what APM mean by quality. And they say this is the fitness for purpose or the degree of conformance of the outputs of a process or the process itself to meet requirements. It's a bit of a mouthful. APM do like to use long sentences, but the idea is quality is this definition of, does it actually do the things we want it to do? So does it do what it's supposed to do and to the agreed standard? And that's really important, that to the agreed standard. That means we need up front to know what those standards are and agree them so that we've got a target to aim for. And quality management is not about exceeding those standards, but meeting them. And that's really quite important in order to save money and save time. If you are old enough, you might remember the adverts that played in the UK quite some time ago, back in the late 80s, I believe, about the Ronseal wood products, so a range of wood stains and paints and things like that. And they had this very clever advertising campaign where they said Ronseal does exactly what it says on the tin, and that perfectly sums up quality. Our thing, whatever it is we're producing, does exactly what it says on the tin, does exactly what those agreed standards says it would. And what's quite interesting is this Ronseal test has become quite common parlance to be used when talking about quality, not just in project management, but just quality in general. Does it pass the Ronseal test? Does it do everything we agreed it would do to the standard we agreed? It's quite interesting. So the Ronseal test is a really good thing to mention, to remember. Weirdly enough, that is actually mentioned in APM's manuals as well. So it's not just something that I've made up, it actually is there. So what do we mean by quality management then? Well, again, APM say it's analysis and control of project outcomes to ensure that they meet the requirements of the agreed scope. Again, slightly long-winded, but essentially it's managing all of the processes, all of the construction steps, the planning steps and everything to make sure we're going to meet those agreed targets for quality, whatever they may be. And we can break down quality management into 4 separate steps or stages, not necessarily run in order, but to run concurrently. So first of all, we're going to have quality planning what quality is and how we're going to go about it. We have quality assurance, we have quality control, which is probably familiar to you, and then we have continual improvement, which wraps around this entire process. So let's start looking at each of those in turn and see what's involved. For quality planning, we're talking about every part or product, so everything we're going to do within the scope. We're going to specify what it is and what constitutes good quality for that. We're also going to talk about the various methods that we're going to use to check that quality so that we can check it and make sure it meets those agreed standards. We don't have a way of checking it. We're never going to know if we met it. It just becomes a pointless exercise writing down some targets. So part of that planning to make sure we can do those is going to tell us what the roles and responsibilities are of various people. So what's the project manager's role, maybe the product owner, the technicians, etc. What is their role within the quality process? What is the construction process to follow? In other words, is there a specific method or a specific order that we should do things in? If you think of something like Lego kits, you get the little booklet with it. And it tells you what the order of construction is, that process to follow to get the correct end product. That's what we mean. What is measured and when? So when we're measuring quality, how often are we going to do that? What is the pass and fail criteria? So if we're checking quality as part of our quality control, how do we know if it is successful or not successful when it matched against that criteria? So we need to set that criteria. What are our control techniques going to be? So how are we going to do quality control? The walkthroughs, the inspections, the measurements, whatever it's going to be that is going to be relevant to your product that you're doing. And also, what's the interactions with other processes? There's no point in designing a really good bit of software that doesn't talk to anything else. That's going to give you problems even if the thing you've produced is amazing and does a really, really good job. So we need to think about all of those things together. So of course, by following this, the reason why we do all of these is because there's lots of benefits for it. So by planning this out and following that plan around quality, it's going to help us eradicate problems. We're going to find them. We're going to identify how often something's going to go wrong so we can fix it. And because we're doing that, that's going to engender confidence in our stakeholders. They're going to be reassured that we know what we're doing. And we're going to be able to demonstrate that through documents to say, we know what we're doing, here is how we're checking it, here's what we do when we find something wrong and how we correct that. So ongoing, our quality continues to go up and up and up, and making sure we're hitting those acceptance criteria around those quality requirements that we agreed. It's going to help reduce redundant work and effort. So if you're producing a particular item and every 1 in 10 of those has to go in the bin, we're wasting time, we're wasting effort, we're wasting resources and therefore money. So we want to reduce those. It's going to help remove risk from the end product. So if you think of building something that's potentially very dangerous, maybe you're designing a new something for a helicopter, the risk of something going wrong, or what the impact of that risk, could be very high and could be life-threatening. So we want to make sure that we're checking everything as we go, that it's going to be able to do the job that it needs to do and do it reliably. Therefore, we're not introducing new risks in that final product, whatever that is. Of course, anything we're doing to cut down the amount of times we're needing to redo stuff, throw stuff away, start again, we're going to be more efficient. And the better we get at that, the more likely we're going to identify opportunities. Actually, why are we using this new thing here when actually we've got something else that we can adapt for this purpose that will do just the job? So it will cut down on the amount of different materials or different tools we need to use, because they all use the same components, the same size screws, the same bolts, the same type of connectors. So if any of you own an iPhone, you'll be very familiar with the idea that every time you change phone, you have to change cable. You can't just grab the nearest cable, plug it in and charge your phone. It's not efficient. There are lots of opportunities for Apple to choose to change that if they wanted to make their phones easier to charge for their customers. They have deliberately made that decision not to do that. Compare that with Samsung, who have done the opposite and have chosen to take that opportunity of saying, hang on a minute, it doesn't actually impact the quality of our product, but it is an opportunity for us to be standardized and cut down on a lot of those extra challenges that come with it. Overall, we're going to be able to reduce the risks, we're going to be able to reduce our costs, and we're going to be able to reduce time spent on these activities by making sure that what we're doing is right first time, every time, wherever possible. And if it isn't, heading towards that situation. So quality control itself is a whole range of different techniques that we can use to ensure that the thing that we're producing meets those quality targets that we agreed. So how are we going to control that? So some obvious ones are visual inspections. Actually go and look at it. Does it look like it's doing what it's supposed to be doing? We're going to take some measurements. Now that might be getting calipers out and actually measuring it. We said it has to be exactly 2 centimeters. We can measure it. Is it exactly 2 centimeters? The answer is yes or no. It's as simple as that. But the next point on here is about that precision of measurement. We say 2 centimeters. Is it okay if it's 21 millimeters instead of spot on 20? What about 20.5 millimeters? How precise does this need to be? And that will obviously vary dramatically depending on your project, of what precision means. If you're creating things like high performance engines and you're talking about pistons inside engine blocks, that precision to get the perfect level of seal and still being able to get those pistons measure, therefore getting the most power out of that engine, you're talking down to very, very, very tiny measurements that you need to be within to meet that 100% or as close to 100% efficiency you can get from the engine, while actually the piston's still being able to move in there. And there's lots, especially in engineering, there's lots of examples like that. Are we going to do things like walkthroughs and playthroughs? So if you're putting together something like a website, you might get people to sit down and actually look for stuff. Get them to click through. Make sure all of those links do work correctly. We're going to get them to use the search bar. Can they find the thing they want? Where you've put the buttons, are they in logical places? Can they find them? So all sorts of things like that we might do with that. I've got playthrough on there as well. For any of you who play computer games these days, you'll be aware that lots of games are released in either alpha or beta versions. In other words, they know it's not finished, but they want people to start playing it. So people start paying money, so they're earning money before they've even finished the game, and the players are doing these quality controls for them, and they're reporting back and saying, oh, this didn't work, or this is clunky, it doesn't work the way I think it's supposed to, and they give that feedback so that the company making that piece of software or that game can go and make those corrections. So they're effectively outsourcing a huge chunk of their quality control, and people pay for the privilege. It's a very smart way to do it, but you are risking reputational damage because people will potentially look at it and go, it's rubbish, it doesn't work, it's broken, it's too broken to be enjoyable, and never come back to it, and obviously not recommend it. The last one on here prevents issues with the final product. So back to our helicopter example, if let's say we're redesigning a gearbox for some reason, we need to make sure that obviously that's going to work effectively once it's installed as a working piece of equipment, rather than just standing alone on a bench somewhere. So quality control, make sure all of those things are in place. Our final product is going to do exactly what we want it to do and not create any more challenges. So we do have a bit of a quality cycle we can look at, where we start off right at the very top here. We've got all of our quality plans, and right at the bottom our quality deliverables, so the products that we're actually going to be handing over to the next stage of the project and potentially hand over to our client or customers right at the end, our end users. So part of this quality plans, we've got the quality standards, so we're writing down what are the standards we need to meet, and we've got that list of acceptance criteria. So what does it need to meet? Once we've checked it and tested it, what is acceptable and what is not acceptable? And as we go from our plans to our deliverables, we're going to have lots of checks and inspections, our quality control stuff. We're going to be checking against that standard to see if it meets it or not, using that acceptance criteria, rejecting anything that doesn't. And obviously anything that does meet it, we're going to pass on towards quality deliverables. But there is a big feedback loop here. So any of those checks and inspections that show something not quite right, we're going to take that information, we're going to improve on it, it's going to go back into our quality control process, so that the next time when we've updated our plans, our checks and inspections are hopefully going to be more successful because we've made changes to either the standards or the process that we're using. So it's going to continue through that with that continual cycle of trying to check to see if we can do things better. So for quality assurance, this is about making sure that people are confident in what we're doing and how we're doing it. Normally verified by an external person, so external to our project, which might mean our senior management team, it might be an external client, it might be the end users. And the way we're going to do this is by producing various bits of paper or documents that they can look at that prove we are doing the right things and that we're under control. So one of the things we can do is make sure our team is trained and qualified and that their training is up to date. As in, our welder has the right qualifications, has the right experience to be doing this. We can now relax knowing that they know what they're doing and they're going to produce good quality welds. Or our security specialist is fully trained in their security, their IT security stuff. They know how to do it. They've got ways of testing to make sure that everything is going to be okay. We can also run audits. So somebody comes in that's not necessarily external to the company, but external to the project, comes in and does some checks. Is everything in place? Can we see some of those documents? And they're going to audit what's going on so that they can then make a judgment, in theory an unbiased judgment, and say, yes, we've had a really good look at this and it's going really well. Or, there are issues, but they've got it under control. And that's the important thing. For quality assurance, it's not about being perfect, but it's about having proper systems and processes in place to correct when it goes slightly wrong. Another thing that helps with assurance is having documented lessons learned. So when things do go wrong, are we writing down what went wrong, why it went wrong, what we can do to fix it, and the results of implementing those fixes. Really important to have that lessons learned because it helps us as project managers grow. It helps our organization grow when it comes to delivering projects or any kind of quality process, but it also works very well for that assurance stuff. It's like, yeah, of course we're not perfect, but we're picking up every time you make a mistake and we're fixing it. Far more powerful than just pretending everything's okay. And of course, you may have supplier accreditation requirements. Now, whether that is you as the supplier or other companies you're using, and they've got certain accreditations saying we only use trustworthy, reliable organizations, and this is how we can prove it, because we only use organizations that have got ISO 9000 accreditations of some description. 9001 being they know how to run stuff, their processes are in place, etc. Can be really, really powerful. So quality assurance is anything and everything that we can do to basically chill out the client and make them feel comfortable that we're in control of stuff. So back to our diagram here, our quality plans at the top, our quality deliverables. We're going to, as we go through this process, from this point of view, we are going to perform audits of some description on some kind of basis. They may not be all the time. They might be only once a while, but we are going to perform audits and we're going to collect that assurance documentation as we go and build that. But just like with the other side, we're going to have the same thing here where whenever we've got feedback, we're going to improve our auditing processes as well as our assurance processes so that our reporting on this gets better and better as well. That brings us on to summarizing this with continual improvement, which is not unique remotely to APM or even to project management, and is a general business term you've probably come across with. And its idea is that we are looking at ways that we can be better and implementing those, and then looking again to say, that's great, we're now better, but how can we better again? What is it we can do to become more efficient, to become quicker, more cost effective, produce higher quality, be more accurate, whatever it is that we need to do, but always trying to improve those. So that's why we've got the continual improvement. So when we put those all together, we end up with this kind of united, our quality plans, what we want to deliver, compared to our quality deliverables, what we're actually delivering, and we have this circular process which completes our continual improvement process of checks and inspections to make sure our product, we're doing the right thing, and that we're auditing and assurancing on those, and we're making improvements to our process and our auditing and assurance processes continually as we go through developing or producing our items until we know that our quality deliverables at the end of the day are meeting everything that we need. And that essentially sums up everything that we kind of need to know within our quality section. It's useful to know that there are other ways of looking at that are totally plausible, and the skill of the project manager is picking which tool to use that's appropriate. So another way we can do that is, again, a standard business tool that works perfectly well is this PDCA. We're going to plan, we're going to set our targets, we're going to write them all down. We're then going to go away and do whatever it is. We're then going to check our results. If necessary, we're going to act upon those results by putting in place improvements and changes. So that's going to affect our plans of how we're going to do it. We're going to go do it again. We're now going to check the results. We're going to act on those results, which is going to update our planning. So the next time we do it, it's going to be better. And as you can see, we just go round and round and round. Plan, do, check, act, plan, do, check, act. And that is that continual improvement cycle. So it never actually ends. So it's kind of useful to think of it in that way as well. And in the real world, it doesn't matter whether you do the strict APM way or you use something like PDCA. It's about using the correct tool for the correct project and making sure that it's followed. Okay, so let's finish off with looking at a bit of an example to bring all of this together. So we're constructing a bridge. Our quality management plan, our QMP, states that we will inspect the steel welds to ensure that they are acceptable. So our quality control documents tell us how we will carry out those inspections. We're going to use X-ray analysis and the frequency, every weld. So every single weld on our bridge, we are going to check using X-ray analysis. Brilliant. So we've got a big part of the picture of what we're going to check, how we're going to check it. And our continual improvement ensures that we look at any time we come across a weld that does not meet the acceptance criteria, we're going to look at it to find out why. What went wrong? Why is this weld not good enough? And it could be that the welder is not trained or needs further training or reminding. It might be the equipment's not right. It might be the conditions they're working in aren't correct. Lots and lots of different things could be a cause of that. We need to find out what they are. And then we need to try and correct those issues through training, environment changes, whatever it might be, correct those issues so that fewer and fewer of those welds fail inspection, which obviously is going to save massive amount of time. It's going to reduce risk and it's going to be cheaper. So the one thing we haven't actually asked, if you want to pause the video in case you're not, it hasn't leapt to mind, just have a quick think. What have we not done? So we've said what we're going to check, how we're going to check it, when we're going to check it, and what we're going to do if it doesn't pass. So the one thing that we are missing is we haven't actually stated how do we know if a weld passes. So we said we're going to check them. We said what we're going to do if they don't pass. Really, really important that we ask that question of, hang on a minute, what is the acceptance criteria here? How do we know if it's correct or not? So this brings us on to our last kind of run of topics on quality, and this is into this thing called configuration management. Now personally, I'm not a fan of the use of the word configuration in this context. It brings to mind something other than what APM want it to bring to mind. But we have to go with APM language, that's important. So the configuration of your project is a set of characteristics of the final deliverables. You're probably thinking, what the heck does that mean? So what we're going to do is, as part of our scoping document, we are going to lay out all of the specifications for all of the parts that we're going to produce as part of this project. Now, for a lot of your projects, there won't be huge amounts of specifications. For others, there might be lots. If you're doing engineering projects, the chances are that you've got lots of detailed specifications for each individual little component. Same within electronics. You can't just chuck any resistor in there. It needs to be the right one. So you're going to specify what resistors, what capacitors, what chips, etc. you're going to need. So I prefer the word specification because we're being specific about those details. They use the word configuration to be a bit more sort of broad than that. But the important thing is we cannot set acceptance criteria unless we have an individual component that we are talking about to set that acceptance criteria for. So configuration management is all about making sure that we are identifying exactly what it needs to be. We're going to define that in the scope so that our quality management plans can look back on that to say that's what we're trying to achieve. Are we able to do that? So having a configuration process enables you to be certain that our tasks or products are being completed to that required standard. Because rather than looking at the minute detail of how we're going to make it meet that standard, you're taking time to actually work out what that standard is. What is that configuration that it needs to be in at the end of your processes? So it will also, and this is important, the tolerances for those accuracy and precision. So we talked about pistons in engines previously. That's exactly what we're talking about here. And we need to specify that as part of the scope. So I've got, for example, here, railway gauge. So this is UK standard railway gauge. The distance between the inside, it's not from the centre of each rail, it's from the inside of each rail, must be 1,435 millimeters apart. That is the distance they need to be. But that obviously, we're talking about rails that are out in all sorts of weathers. They're made of steel. They contract and expand in different weather. So there is a certain amount of tolerance that they can be. And those tolerances at time of writing this was it can be up to 6 millimeters wider or 3 millimeters narrower than that. So we know exactly when we're measuring that, if we go, well, actually, this bit is only 1,434 millimeters, is it acceptable? Yes, it is within tolerance. So we can let that go by. So we need to make sure we define that. It's really, really important. So we now have this huge list of different items, whether that's individual components, they might be building plans that potentially change over time, where the windows are going to be, how thick the walls are, what type of insulation, all of those things we're going to have. And if you can imagine, we've got all of these big plans on big scrolls that you still see on TV across desks that people are looking at, the plans that we're following. That's all part of the configuration management. We're taking those plans and putting them into action. But we do have quite a big challenge, which is managing that. And that's where our next role comes in, which is the configuration library. So all of those desired specifications, those planning documents, and all of those are, in theory, kept together in one place that's known as the configuration library, because it's a library, a collection of all the configurations for all of our things within our project. Now, of course, depending on the size of your project, this might just be one small folder on your desktop. Alternatively, it could be a huge national archive full of all sorts of things on a major, national size infrastructure project. If you think of things like the building of the Channel Tunnel or the HS2 rail links, expanding an airport, a major airport, to include an additional runway, they are massive, massive projects. You're going to have a huge volume of quality information and data and things like that. So you're going to need to keep them all in one place, and importantly ensure that they're kept up to date. So you're only using the latest versions, and you're not getting mixed up with past versions, because that's when the wheels fall off. So in order to do that, we need a configuration librarian. And that might sound weird, but that's a real job. They're not often given that particular title, but that is their job. And they curate all of this information and data, and they're responsible for making sure that everything is available, everything is kept in store. We've got old copies as well, and the really, really important thing is that version control. So we need to make sure as plans change, we make changes through our quality process. We might have requests to change our scope from the customer, all sorts of things that may change. This person is responsible for making sure that those new updates are given out to the correct people as soon as possible, and that they understand how that changes that. So there's quite a perhaps a silly example, but it's plausible that I've got here, is legislation does change. Now, normally in the building trade, construction, you have quite a long lead into that, but that doesn't mean they can't happen on short term, and it doesn't mean that we can't miss them. So we are going to build a whole bunch of houses here, and the legislation changes to say that actually the distance between the road curb, and the wall of the property has to be a minimum of 2 meters to allow wheelchair access and prams and things like that to pass. So that's what's just one I've made up. It's not true. I've made it up. Don't run off and panic. But our original plans, we were going to be 1.5 meters from that curb. If you've got those old plans with the builders and they build all those houses only 1.5 meters away from that curb, they are in breach of that legislation. All of those houses are going to have to be torn down. I will let you work out the consequences for that. It's not going to be pretty. So you can see in that kind of example that version control is really, really important and vital. And of course, in those kind of bigger projects, the project manager can't possibly do it all, and we need to delegate that work out. They're still in charge. They still need to make sure it's happening, but a configuration librarian can focus just on these challenges, reporting back to the project manager, and make sure these things all happen correctly. So that brings us to the end of this particular topic. I hope that's been useful. I hope that's kind of explained some of it. It's a little bit tricky because every project is unique, and therefore what quality means to every project is kind of unique as well. Obviously, there's certain things for the exam that are kind of set in stone from APM's point of view, but in the real world, you have to be flexible and pick and choose which tools you're going to use and how frequently. Just remember, it's all about that Ronseal test. Does your final product do exactly what it's supposed to do as defined and agreed with the end users? I hope you found this useful. Please leave a like and a comment. There'll be a couple more videos to follow up to finalize this series, and I hope to see you in the next one. Thank you.